Let's wait till it stops shaking. Okay, team, welcome to Module 2. We're going to talk about plurality with elimination, the method of voting, and specifically when it comes to truncated preference ballots, because that's a lot like the example in class, the one where we all voted on the most random number between 1 and 20. We had this truncated preference ballot, and we were going to use plurality with elimination to see what we got for the result. There's some confusion on how to do that, so we're going to jump right into that here. Let's say we have this pool of candidates. Let's say our candidates are A, B, C, D, and E. And I'll set up a table kind of like the one we had in class, where we'll have first and then second and third. And then let's add a column for the number of voters. And so these won't each be one single ballot. There are some repeated orders, and so we will have the counts for each of them in this row here. So first of all, we'll take two voters who had A, D, C as their order, and we have 6 who have B, A, C, and then 2 who have B, A, D, and then we should probably be separating these so that we don't get too confused. And then we have 1 CBA, and we have 1 CDA, and we have 4 DAE, and then 4 we have 4 ECD. Okay, so what we'll do first is we'll write down each candidate's number of first place votes, and then start eliminating from there. So we've got our candidates A, B, C, D, E. And let's take a note of how many votes are needed for plurality. So our total number of voters is whoops, I'm sorry, this was supposed to be a 4 here. Sorry, there were 4 people who had this particular ballot. Okay, so yep, and the rest of it is good. Okay, so we have 10 plus 2 is 12, plus 2 is 14, plus 8 is 22. So total 22 voters. So that means we need more than half of that has to be going to one candidate for them to have the majority. And so what we'll do is we'll say that we need, so half of 22 is 11, so we'll say we need 12 points to win. So with that in mind, we count up the number of first place votes that each one gets. We have that A has 2, B has 6 plus 4, so B has 10, C has 2, D has 4, and E also has 4. So what we'll do next is take the two candidates that are in last place, this A and C, who both have 2, and eliminate them and reassign their votes. So first off, let's start by eliminating C. So we're gonna first cross out every C that appears here. So we'll say no, nope, 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 nope. And that's probably all, but maybe I missed one. We'll find out. And we'll cross this out. And we need to reassign every ballot from this row and every ballot from this row. There's just one in each row. 1 point goes to B, and 1 point goes to D. So let's give D 5, and let's give B, this one goes to 11. Great. Next we have to eliminate A. So let's give away A's points. So let's first cross out every A. I really should have done this with a different color, but here we are. So I think every A is crossed out, and let's take everyone who voted A first voted D second. So let's give both of these points to D. D now has 6 points, and A is voted off the island. Notice that still hold up a second. D has 4, now D has 6. B has 11. First have 10. Whoops, okay, so D should actually have 7 now, because we added 1 to D when we eliminated C. So D started with 4, added 1, made it 5, and now we added 2, so we made it 7. Okay, now we're good. The total number of points should add up to 22 until points start disappearing at some point, which can happen with this type. Okay, so moving on. Notice that still no candidate has the majority yet, so we go again. Now we're eliminating E, so let's cross out every E. That's every E, and let's try to give E's points away. So everyone who voted for E first voted for C second. Let's give those points to C. Oh, whoops. We can't do that because we've eliminated C. So we're instead going to give them to D. So going ahead and giving 4 points to D, we give, so let's cross this out, and then 7 plus 4 is 11. And in this case, we have resulted in a tie between B and D. They each have exactly 50% of the vote, and there's nowhere we can go from here. So this would be a situation where we'd have to redo the vote or something. But if we were to eliminate another candidate, for example, just for argument's sake, let's talk about what you would do if we did eliminate one of these. If we were to eliminate D, which we shouldn't do because they're tied, but let's pretend that one of them is lower than the other. If we were to eliminate D, we would cross out all of the D's, and then we would try to reassign these D votes to the next one, but because A is eliminated and E is eliminated, these points would just disappear. So we would not give these votes to anybody. And then we would declare B the winner. So that's what we do in that case. Okay, so now we're just going to talk about a little bit of new material, but it's not really problem strategies. It's more just a little bit of philosophy about elections. So there's this guy who's a Nobel Prize winning economist named Kenneth Arrow, and this is him there, and he came up with 4 criteria that he determined are necessary for a voting method to be fair, and we're going to talk about each of those. So this is about like the philosophy of determining the best voting method, but that's really difficult to do, so instead we'll just talk about how do we even determine if a voting method is fair. So the first criterion is the majority criterion. So I'll put criteria on the top. So majority, and this just states that if a candidate has the majority, that candidate should win. So cool. So if it's possible if a voting method allows a candidate with the majority to not win, then that, according to Professor Arrow, then that voting method is not fair. Next is the Condorcet, the Condorcet criterion. And this is that if a candidate beats all the other candidates in an individual pairwise comparison, then that candidate should win. So slightly different, but if there is such a voting method that a candidate who does beat every other candidate in pairwise comparison, so you compare it to every one, and if it gets all the points, if that candidate doesn't win, then the voting method is not fair. Okay, so next is the moneticity condition, or the moneticity criterion. Oh, sorry. I am so bad at reading sometimes. It's monotonicity. So many syllables. Wow. Okay, here we go. We're moving now. So monotonicity. So if a candidate wins, then it must be true that the candidate would still win if they were moved higher on any ballot. So what we're saying here is that moving a candidate, if a candidate were to win, if a candidate wins, it must be true that moving them up in any individual's ballot would not hurt them. So that's what we're saying here. Candidate would still win if they were higher on any ballot. Monotonicity. Great. Okay, so now the final condition here is and this is a really long name, the independence of irrelevant alternatives condition or criterion. This is another way of saying irrelevant candidates. Alternatives is sometimes used as a different word for candidate, but they mean the same thing. And this is that if a candidate wins, then the candidate would still win if any losing candidate were eliminated from the ballots. So this is like a candidate who wins must also win in the same, if you apply the same voting method to the election without that candidate on any of the ballots. So that's what that means. And so Professor Arrow is saying that an election or a voting method must satisfy all of these to be fair. And, whoops, I'm moving the whole studio here. Jeez. And guess what? We're going to be a real down. I'm going to be a real downer here and just make a column to this. I'm going to make this into a table. And I'm just going to add a column here. And this column will be for, and I'm not sure if you can see all the way up here, but it's going to be for voting methods that violate the criteria. So and you can look in the book, you can get it on reserve in the library, or have an old edition or whatever. The book has examples, counterexamples that show all of this. So the board account method, that one violates the majority criterion. The plurality method violates the Condorcet criterion. And then the plurality with elimination method violates the monotonicity criterion. And pairwise comparisons violates the IIA criterion, the independence of irrelevant alternatives. So I wrote p-wise here. I'm talking about pairwise, not Pennywise the dancing clown. So what we have here is that democracy has no way of being fair, or not that we know of. So that's too bad. Sorry. Yep, I'll see you in class.